Good morning, class 10C. We have come to the end of the syllabus. This will be our last chapter. Before this, we discussed about the study of compounds, about four compounds: uh, hydrogen chloride, ammonia, nitric acid, and sulfuric acid. Now, if you remember, in the beginning of our session, in the month of March, or at the last week of Feb, we have started a chapter called organic chemistry, and we came to know about the basics. That means how to write down the IPAC name, that is nomenclature. Okay, and we have studied up to there, and we have left the topics hydrocarbons, about alkanes, alkenes, and alkynes. Okay, now today we are going to see about it. So hydrocarbons, alkanes. Hydrocarbon means the organic compounds which contains only carbon and hydrogen. And if you want to classify hydrocarbons, it is classified in two types: aliphatic or open chain compounds, and cyclic or closed chain compounds. So in this we'll discuss about only this aliphatic one. This aliphatic one is further classified in two types: saturated alkenes and unsaturated alkenes. Saturated alkenes, which is also known as paraffins because they are less reactive. The general formula is CnH2n plus 2, whereas unsaturated means the hydrocarbons which has got a double bond and triple bond: alkenes and alkynes. Alkenes have got the general formula CnH2n, and alkynes have got CnH2n minus 2. Okay, so this is the general idea about the hydrocarbons and their classification. Now we'll focus on alkenes first. Okay, alkenes. So alkenes, the first alkane with that general formula CnH2n plus 2 will come as, if you put the value for n equals to 1, it becomes C1H2 into 1 plus 2, that will be CH4. And the structure formula is this one: carbon and having attached to 4 hydrogen, and in the short form it is written as CH4, and the name is methane. Okay, if you have got the value for n equals to 2, you'll get ethane C2H6. The structure is like this. Okay, or it can be also written as CS3, it's ethane. Similarly, propane C3H8, the structural formula is this one: 3 carbon atom attached, and further remember that the carbon has got the valency 4, so it should be form 4 bonds always. So this is propane. Similarly, butane, we have got butane, isobutane, pentane, like this. Okay, so just to go to the structural formula of this compound, we have already practiced all this in our class. Now, isomers of butane. Isomers, there is a term called isomers. Isomer means the compounds having the same molecular formula but different structures. So butane means having 4 carbon atom, so C4H10. So 4 carbon atom, 1 2 3 4, and the molecular formula is H10, 3 5 7 10. Okay, C4H10. And the name for this will be, since we have got a straight chain, we have got 4 carbon atom, so the parent name will be but, and since all are single bonds, so ANE, butane. Okay, similarly with the same molecular formula C4H10, we can write in this way. Okay, this is the branch one, so we have kept 3 carbon atoms straight and 1 we have kept it as branched. Now if you count the number of carbon atom and hydrogen, it is same as this one, C4H10, but the name for this will be, since you have to, in writing the IPAC name, you have to give the number, and you can number it from any side because the substituent occupies the middle position, 1 2 3. So at 2 we have got methyl, CS3 is methyl, so we write 2 methyl, and since we have got 3 carbon atom, propane, because 3 carbon atom means prop, and since it is a single bond in propane. Okay, so we have got isomers, two isomers of butane. Similarly, if you see the isomers of pentane, we have got 3 isomers. One is normal pentane, where we have got the 5 carbon atom in the straight chain. Okay, this is called as normal pentane. Then we can just have a branch one, 4 carbon atom and 1 is branch, so the name for this we can write 1 2 3 4. So at 2 we have got a methyl group, so 2 methyl butane, or we also call isopentane. Okay, got it. Next, this one we can also make an such arrangement where we have got 3 carbon atom straight and 2 we can make it branched. So in this case, this at 2 we have got 2 methyl groups, so we'll mention 2 dimethyl because of 2 methyl, and this is the propane. Okay, or we call it a neopentane as well. So we have got 3 isomers of pentane. Next, we'll discuss about methane and ethane, especially in alkanes. Structure of methane is this one. This is the electron dot formula or Lewis dot formula. The structure formula is this one if you form a bond, and the actual structure is this one, which is known as tetrahedral, where the bond angle is 109.5 degree. Laboratory preparation of methane. How we can prepare methane in lab? So the reactants or the reagent used is sodium ethanoate, sodium acetate, and soda lime, where soda lime is the mixture of sodium hydroxide and calcium oxide. Okay. Now, procedure is a mixture of sodium ethanoate, that is sodium acetate and soda lime, is taken in a hard glass test tube as shown in figure and heated with a Bunsen flame. So in this test tube, glass tube, we have taken sodium acetate and soda lime and it is heated. So when these two reactions takes place like this, sodium acetate and sodium hydroxide in presence of calcium oxide, because this soda lime mixture, it will form sodium carbonate and methane gas is produced. So the methane gas that is produced in this tube will travel through this and it will be collected over here. Okay, so the collection is the gas evolved is collected by downward displacement of water, since it is slightly soluble in water and is lighter than air. Okay, so this is the whole process. Now, laboratory preparation of ethane is also in the same way. The just thing you need to replace is that sodium ethanoate by sodium propanoate and soda lime. Same procedure. A mixture of sodium and soda lime is taken in the boiling tube and heated with a Bunsen flame, and the reaction will take place in this way. This is sodium propanoate with soda lime mixture will give you sodium carbonate and ethane, and the collection method is the gas evolved is collected by the downward displacement. So the laboratory preparation of methane and ethane are same, only the thing is that you need to change the reactants. Next, other methods of preparation of methane and ethane. So we can prepare methane from methyl iodide or iodomethane. So when methyl iodide is heated with hydrogen in presence of nascent hydrogen, we call it, forms methane and hydrogen iodide. Similarly, for the preparation of ethane, we can take a ethyl bromide and heat it with hydrogen to form hydrogen bromide. Sorry. So nascent hydrogen is produced by the action of zinc powder and dilute HCl. Okay, so this to produce this nascent hydrogen, we can use zinc powder and dilute HCl. Ethane can also be prepared from alkyl halides, and this is a very important method. So when methyl iodide or methyl bromide is warmed with sodium metal in the presence of dry ether, ethane is produced. So when you take methyl iodide and treat it with sodium metal in presence of dry ether, it is going to form ethane and sodium iodide. This reaction is a naming reaction which is known as Woods reaction. Okay, by this method we can't prepare methane, we can only prepare ethane or higher alkanes, we can say. Okay, next, chemical reactions of methane and ethane. Complete combustion, that means what will happen if you completely burn methane and ethane. So methane and ethane burn in air with a bluish non-sooty flame to form carbon dioxide and water, since it is a hydrocarbon. A large amount of heat is also given out, so alkanes are good gaseous fuels. So methane, when is treated with oxygen or burned in presence of oxygen, it forms carbon dioxide and water. And ethane, when burnt in presence of oxygen, it will form carbon dioxide and water. Substitution reaction with chlorine. So what will happen if you carried out the substitution reaction with chlorine to the methane and ethane? So CH4 methane in presence when it treated with chlorine in presence of diffuse sunlight, because this reaction takes place in presence of light, what will happen? Out of this 4 hydrogen, 1 hydrogen will be replaced by chlorine. That means it will form CH3Cl and HCl. 1 hydrogen will be gone with that chlorine and it will form HCl. Similarly, further chlorination, the reaction is like this. This hydrogen will be replaced by this chlorine atom. Okay, this chloromethane, or we call methyl chloride, is formed. Similarly, this chloromethane, when treated with further chlorine atom, what will happen? 1 more hydrogen will be replaced. So it will become CH2Cl2, that is dichloromethane plus HCl. Similarly, this dichloromethane further reacting with chlorine can replace that 1 more hydrogen. It will form trichloromethane, which is commonly called as chloroform, CHCl3 plus HCl. And finally, we have got 1 more hydrogen that can be also replaced by the chlorine atom to form carbon tetrachloride, okay, plus HCl. This is the substitution reaction of methane with the chlorine. In a similar reaction, it takes place with the ethane as well. Uses of methane and ethane. Methane is a source of carbon monoxide and hydrogen. It is used in the preparation of compounds like acetylene, formaldehyde, methanol. It is used as a domestic fuel. Okay. Domestic fuel means it is used in the preparation of LPG, liquefied petroleum gas and all. Ethane is used in the preparation of ethene, ethanol, acetic acid. 1,1-trichloroethane is used in dry cleaning. So these are the few uses of methane and ethane. To this assignment 9. Question number 1, draw the structure of isomers of butane and pentane. Question number 2, how is methane and ethane prepared in the laboratory? Question number 3, write the equations for the complete combustion of methane and ethane. And question number 4, convert methane into chloroform, methyl iodide into methane, and ethyl bromide into ethane. So complete this assignment and send it in my mail.